I have to admit the Eiffel Tower was one of our first kind of demos as well. We were super impressed. We had a thesis around additive manufacturing going into semiconductor manufacturing at some point, but we hadn't really found where and how until we met Fabric8. And part of the reason we were so excited is the process is just so unique. One is they don't use powders, right? Metal powders. They're using liquid copper, which copper is used in semiconductor manufacturing and electronics. It's super conductive. Maybe just talk about what is the specific process you're using and why is that liquid copper so game changing?
Yeah. It really is quite different. And you alluded to it already, Jen, is that when you look at metal 3D printing out there today, it really is based on powder, metal powder. And there's a couple methods that are really common. There's a laser-based laser powder bed fusion where you're basically tracing a laser, you're melting the part, and you're melting powder on top of that part as you're building it. The other one that's really popular is binder jetting. That's when you're mixing the powder with binding agents, and then you're sintering it to densify the part. But this comes with a lot of constraints that we can talk about in a moment. But our process, ECAM, as you mentioned, it's liquid-based. So what we've done here is we're combining electrochemistry or electroplating, that thin film coating technology that I was mentioning earlier, also the same type of electroplating that's used in semiconductor packaging to fill vias and do things like that. And we've taken electrochemistry and combined it with display technology. And what I mean by display technology, it's the same type of display that's in an iPhone or a flat screen TV or a monitor. And the way that the system works is you can imagine at the bottom of the chamber, there's a display. Just picture a screen or an iPad on the bottom. Then we have a plate on the top. Your build plate's on the top, parts are built up there, the display's on the bottom, and the plate moves up and down. And then we'll flow that water-based solution in between the two plates. Now we have this copper that's in a water form flowing between the plates. And because we're using a display, now imagine we can activate any image or any picture that you want. Whatever image we activate on the display, it will project onto that top plate and start to deposit metal in that pattern. And that's incredibly important because when you dive in, these pixels are anywhere from a half to a third to a 1/5 the thickness of a human hair. So now we've got incredible resolution, incredible precision at how we can control and deposit copper. And we're using this water-based feedstock, which allows us to basically use raw copper at the spot price of copper versus these metal powders, which cost hundreds or even into the thousands of dollars per kilogram. We're talking about raw copper for the spot price, which is maybe $9 a kilogram.
And you talked about that display part. That has been part of the main development that the company has had to do over the last 3 years. Now, the company seems to be adding about a printer a day, really getting that manufacturing up. So maybe just talk about status. Where are you guys at? Product readiness?
Yeah, it's definitely been a lot of investment to get the technology from very small scale stuff early on around that Series A time. We had about a 1-inch by 1-inch build area. And now we've scaled up that build area to about 5 inches by 5 inches in print area. And we've upgraded our equipment to be essentially a production tool rather than an R&D tool. And that production tool is now being deployed, as you mentioned, into our pilot production facility. We have a full pilot scale production plant that has a capacity of about 240 printers. And today we've got just under 50 printers built into that facility. And so it's really exciting to see the deployment, how fast we are able to build and deploy printers. These printers are very efficient machines, so they're simpler to build, let's say, than a very complex laser system. And so that's how we can deploy them at the rate that Jen was mentioning, about a printer a day. And each of these printers has the capacity to generate a significant amount of part volume. And we're targeting some early applications in thermal management and RF that will go into market later this year.
That's a lot of Eiffel Towers. No, I'm just kidding. Can you tell us what kinds of things you're making? And also, I'm just curious, like, how big are these printers?
The printers themselves are about the size of maybe a small refrigerator. So you can line them up very sequentially side by side. And then you can feed them all with one plumbing system, which is one of the other benefits of using this water-based feedstock. We don't need to bring raw material to the printer. We just have a plumbing system that allows us to provide the raw copper feedstock to each printer. So it makes it easier to scale up those units. You can just imagine a row of these small refrigerator-sized machines just extending out.